What's up guys, this is Mansky. Welcome to another video. In this video I want to show you some examples regarding limits at infinity. The first example here I have limit of 5 minus 4x to the power of negative 3 plus 3 times x to the power of negative 5 when x approaches infinity. I can write it as limit of 5 when x is approaching positive infinity minus 4 limit of 1 over x to the power of 3 when x is approaching infinity plus 3 when limit of 1 over x to the power of 5 when x is approaching infinity. You know, when we have the negative exponent, we can bring it in the denominator. So limit of 5 when x approaching infinity is going to be 5 minus 4 times when x is approaching infinity, this limit is going to be 0 plus 3 times limit of 1 over x to the power of 5 when x approaching infinity, which is going to be 0 as well. So that's going to be 5 minus 0 plus 0 is going to be equal to 5. Next example is limit of 10x squared minus 7x over 4x to the power of 5 minus x squared plus 3 when x is approaching positive infinity or negative infinity. In this example, what we need to do, the denominator, the largest exponent of the denominator is x to the power of 5 and then the numerator is x to the power of 2. So what we need to do, we need to multiply both numerator and denominator by x to the power of negative 5. So that's going to be a limit of x to the power of negative 5 times 10x squared minus 7x, and here x to the power of negative 5, 4x to the power of 5 minus x squared plus 3 when x is approaching positive infinity or negative infinity. That's going to be 10x to the power of negative 3 minus 7x to the power of negative 4. And here we have 4 times, these two cancel out. X to the power of negative 3 plus 3x to the power of negative 5 when x is approaching positive infinity or negative infinity. So the numerator is going to be 0 and denominator is going to be 4 minus 0 plus 0, which is going to be 0 over 4, and the answer is going to be equal to 0, because 0 divided by 4 is 0. Next one, limit of 5x to the power of 7 over 2 minus 7 x to the power of negative half over x squared minus 2 x to the power of half when x is approaching infinity. So I multiply both numerator and denominator by x to the power of negative 2, 5x to the power of 7 over 2 minus 7x to the power of negative half, x to the power of negative half, x squared minus 2x to the power of half. That's going to be limit of 5x to the power of 7 over 2 minus 2 is going to be 3 over 2 minus 7x to the power of negative 5 over 2. Here we have 1 minus 2 x to the power of negative 3 over 2 when x is approaching infinity, which in this case is going to be limit of denominator is going to be 1 minus 0 and numerator is going to be 5 times infinity minus 7 times 0, which is going to be infinity. And we can say that since the largest exponent on the numerator is greater than the largest exponent on the denominator, when x approaching to positive infinity, the whole limit is going to be positive infinity. Next example is limit of x squared over square root of x cubed plus 1 when x is approaching infinity. So what we can do, we can say that's going to be equal to limit of x squared x cubed plus 1 to the power of half. Then we can multiply both numerator and denominator by x to the power of negative 3 over 2 when x is approaching infinity. That is going to make it as x to the power 1/2, and here we're going to have 1. when x is approaching infinity. That's going to be equal to infinity. And we can also say that since the order of the numerator is 2 and order of the denominator is 3 over 2, since the numerator is greater than denominator, when x is approaching infinity, the answer is going to be infinity. Next one. Calculate the limits at infinity for f of x, 12x plus 25 over square root of 16x squared plus 200x minus 300. That's going to be limits of 12x plus 25. And here you have 16x squared plus 200x minus 300. And x is approaching infinity. The order of the numerator is 1, the coefficient is 12, and the denominator, the order is 1 as well. Square root of 16 is going to be 4. So the answer is going to be 12 over 4, which is going to be equal to 3. Next example, limit of x over x plus 9 when x is approaching infinity. What we can do, we can multiply both numerator and denominator by x to the power of negative 1. That's going to make it as limit of 1 over 1 plus 9 x to the power of negative 1 when x is approaching infinity. The answer is going to be 1 over 1 plus 0, which is going to be 1. And we could also say that since the degree of the numerator and denominator are the same, and the coefficient divided by coefficient is going to be 1, when x is approaching infinity, the limit is going to be equal to 1. Next example is going to be the same thing. Since the order of the numerator and denominator are the same, the coefficient here is 3 and here is 4. When x is approaching infinity, the answer is going to be 3 over 4. However, if you want, you can multiply that by basically x to the power of negative 2, 3x squared plus 20x, x to the power of negative 2, 4x squared minus x, when x is approaching infinity. That's going to be limit of 3 plus 20x to the power of negative 1, 4 minus x to the power of negative 2 when x is approaching infinity. These two is going to be 0, so we have only 3 over 4. Next one. 3x squared minus 16x over 2x to the power of 4 minus 3x squared x cubed plus 30 when x is approaching infinity. As you see here, the order of the numerator is 2 and the order of the denominator is 4. So since the order of the numerator is less than the order of the denominator, we can say that when x is approaching infinity, the whole limit is going to be 0. Or what we can do, you can multiply both numerator and denominator by x to the power of negative 4, and what you will see that like that. And the answer is going to be 0 over 2, which is going to be 0. Next example, limit of 4 over x plus 5 when x is approaching infinity. What you can say, as you see here, the order of the numerator is less than the order of the denominator. So when x is approaching infinity, the limit is going to be 0. So I'm going to say 4 times x to the power of negative 1 and x to the power of negative 1 times x plus 5. When x is approaching infinity, that's going to make it as 4 times 0 over 1 plus 0, which is going to be 0 over 1, and that's going to be equal to 0. Next example, you have 7x plus 9 over 4x minus 5 when x is approaching infinity. The order of the numerator and denominator are 1. They are the same, so the limit of this rational function is going to be the coefficient of the numerator and the leading coefficient of the denominator, which is going to be 7 over 4. Or you can also multiply both numerator and denominator by x to the power of negative 1 and find out the limits. When you evaluate it, that's going to be equal to 7 over 4. Next one. Limit of 9x squared minus 1 over 5 minus 27x when x is approaching infinity. In this case, as you see here, the order of the numerator is 2 and the order of the denominator is 1. So when x is approaching infinity, the answer has to be infinity. Let's check. I basically multiply both denominator and numerator by x to the power of negative 1. So this part and this part is going to be 0. The answer is going to be infinity over 27, which is going to be infinity. Multiply by 9 over negative 27. So it's going to be negative infinity. And here we have limit of 7 x squared minus 19 over 4x plus 1 when x is approaching negative infinity. What you need to do, we need to multiply both numerator and denominator by x to the power of negative 1. That's going to be limit of 7x minus 19x to the power of negative 1, 4 plus x to the power of negative 1 when x is approaching negative infinity. When x is approaching negative infinity, this part and this part is going to be 0, and we're going to end up having limit of 7x over 4 when x is approaching negative infinity. The answer is going to be negative infinity. Next one, limit of 5x minus 1 over 7x cubed minus x plus 11 when x is approaching negative infinity. So what we need to say here, since the leading coefficient of the numerator is 5 and the order is 1, the order of denominator is 3, since this is less than the denominator, the limit is going to be 0. Let's check. I need to multiply both numerator and denominator by x to the power of negative 3, which is the largest exponent in the denominator. So that's going to be 0 over 7 minus 0, which is going to be 0 over 7, and that's going to be equal to 0. Next one, limit of 3x cubed minus 1 when over x plus 5 when x is approaching infinity. As you see here, the order of numerator is 3 and the order of denominator is 1. So since the order of numerator is greater than the order of denominator, when x is approaching infinity, the whole limit is going to be infinity. Let's check. When you multiply both sides, both numerator and denominator by x to the power of negative 1, that's going to be limit of 3x squared minus x to the power of negative 1, 1 plus 5 x to the power of negative 1 when x is approaching infinity. Now this part and this part is going to be 0. We have 3x squared. Limit of 3x squared when x is approaching infinity is going to be infinity. Next example. 2x to the power of 5 minus 3x to the power of 4 plus 11x squared over 8x to the power of 4 minus 7x to the power of 2 plus 11 when x is approaching negative infinity. So the largest exponent of the denominator is x to the power of 4. So what we need to do, we need to divide both numerator and denominator by x to the power of 4. It means that we need to multiply by x to the power of negative 4. So that's going to be limit of x to the power of negative 4 times 2x5 minus 3x4 plus 11x squared over x to the power of negative 4, 8x4 minus 7x squared plus 11, and x is approaching infinity. That's going to be 2x minus 3 plus 11x to the power of negative 2 over 8 minus 7x to the power of negative 2 plus 11x to the power of negative 4 when x is approaching negative infinity. So as you see here, that's 0. You have infinity, 2 times infinity minus 3 over 8 minus 0 plus 0, which is going to be infinity. Next one, limit of square root of 9x4 minus 3x plus minus 11 over 4x cubed minus x plus 5 when x is approaching infinity. In this case, what I'm going to do, we have 9x to the power of 4, and here we have 4x cubed. So what we have here is basically is going to be limit of 3x squared, and here we have 4x cubed. And x is approaching infinity. Since the order of the denominator is greater than the numerator, the answer is going to be 0. Here, what we have is square root of x cubed plus 20x squared minus 11 over 10x minus 2 when x is approaching infinity. We can say that's going to be the same as x to the power of 3 over 2 over 10x when x is approaching infinity. Since it's greater than this one, the answer is going to be infinity. Next example, we have 8x squared plus 7x to the power 1 over 3 over square root of 16x to the power 4 minus 6x when x is approaching negative infinity. What we have here is going to be limit of 8x squared over 4x squared when x is approaching negative infinity. And since the order of numerator and denominator are the same thing, that's going to be equal to 8 over 4, which is going to be equal to 2. Next one is limit of 4x plus 5 when over square root of 25x squared minus 14x when x is approaching negative infinity. That's going to be equal to limit of 4x over 5x when x is approaching negative infinity. These are the same, and the limit is going to be 4 over 5. Next one, limit of x to the power 4 over 3 plus x to the power 1 over 3 over 4x to the power of 2 over 3 plus 1 to the power of 2. That's going to be basically limit of x to the power 4 over 3, 4x to the power of 2 over 3 to the power of 2, when x is approaching infinity. And that's going to be since the order of numerator and denominator are the same, when it approaches infinity, the answer is going to be 1 over 16. Next one is going to be limit of x to the power 4 over 3 minus 9x to the power 1 over 3 over 8x to the power 4 plus 2 to the power 1 over 3 when x is approaching infinity. The largest exponent of numerator is 4 over 3, and the largest exponent here is going to be 4 over 3, which is going to be limit of x to the power 4 over 3, 8x to the power 4 over 3. And here, 8 to the power 1 over 3. When x is approaching infinity, is going to be 1 over 2, because the cube root of 8 is going to be 2. Next one, limit of absolute value of x plus x over x minus 3 when x is approaching negative infinity. Since x is negative, this one is going to be negative x. So negative x plus x over x minus 3 is going to be 0. And here, limit of absolute value of x plus x over x minus 3 when x is approaching positive infinity is going to be limit of x plus x over x minus 3 when x is approaching positive infinity. So that's going to be limit of 2x over x minus 3 when x is approaching infinity is going to be equal to 2. So these are the examples I had for today for limits of infinity. I hope you enjoyed this video. Please don't forget to subscribe to this channel. You can have access to many other videos regarding calculus, physics, and chemistry. Please leave me a comment if you have any question and I'll get back to you as soon as possible. Thank you for watching and have a great day.